者，请启吞麦口。
Okay, so good morning to everyone. So today we're gonna finish chapter 2, and then we are going to chapter 3, talking about how you differentiate the basic functions, how you differentiate constant, polynomials, triple, logarithm, exponential. Okay. All right. Let's review derivative from last class. Okay. By the way, our quiz one will be on next Tuesday. So next Tuesday it will be released at 3 p.m. So you got 1 day to read. Okay, so maybe I'll talk about instruction later when more of you come. All right. Let's review on derivative. There are two equivalent definitions that we introduced last time. So basically, let's start from one example. Let's say fx equals square. Okay, so how about look at the point, let's say 2, okay. So the first way to talk about derivative was the tangent line. Okay, so it's the gradient of this tangent line here. Okay, so we can figure out this tangent line at the point 2, 4, right? Okay, so how do we realize this tangent line here? Remember, we realize it as a limit of nearby secant. Okay, we realize it as a limit of a nearby secant. So for example, maybe I join this 2, 4 with the other point on the curve, right? Okay. And then I realize that if I take a bunch of sequence of these nearby secants, right, then it will converge to this orange tangent line. Okay, you can do it similarly from the other direction. Okay, so this translates to the formula on the gradient of this line. Okay, so m tangent is the limit where h goes to 0, and you compute the difference of f of a plus h minus fa over h. Okay, so this is the I think you need to remember the gradient formula from your high school, which is y2 minus y1 over m2 minus m1 equals to, x2 minus x1 equals to m1. So now we are putting limit, okay, limit on both sides. Okay, so this is one way to see a derivative. The other way to see derivative was imagine that this curve, okay, there's a particle, okay, that flow along this curve, okay, but you want to ask how fast is it on that point 2, 4. Okay, so we also realize this limit. Okay, we define the instantaneous velocity. So this is instantaneous velocity. Okay, to be at v to be the limit of also h to 0 of f plus a plus h minus fa of h. Okay. So let's say 2, 4 is the point that we're interested. So what's our A in this example? What's our A in this example I drew? Sorry, 2. Okay, our A is 2. Okay, so in our example, take A equals to 2. Okay, so here also take from. Okay. Okay, so since this definition is very useful, right? We will call this as the derivative. Okay, so then the derivative f prime a, okay, of f at x equals to a is just this limit of the new function that we define now. So it's the limit of the new function, which is f of a plus h minus fa over h. Okay, so it's like the limit of the difference in y, okay, in y direction over the difference in x direction. Okay, okay, so in the previous section, we study limit of function. Now we study a limit on a function that build up like that. Make sense? And so this is a new function. If you compare to like x, which is the gradient of the secant. Okay. So right. So not that we actually can rewrite this limit here. We can replace a plus h by, let's say, b. Okay. So let b equals to a plus h. Okay. So if h goes to 0, that means that b will go to a. Make sense? This one? Okay. Yep. So we can rewrite this limit here to become b go to a, and then fb minus fa. So what is h? H is just b minus a. Okay. So this one is more appearance. You can see that b and a are different axes, and then fb and fa is really look at the difference of value of f taking at b and a. Yeah. Okay. So in this case here, if we want to rewrite it in an easier form, it is like this. So like we are having a limit of a change of y, the ratio of change of y versus change of x, and then taking the denominator going to 0. Can you see from here that we cannot substitution, cannot divide by 0. Okay, but the point here is this function here might not be continuous at 0, but the limit would. The limit would. You could have limit, but you cannot evaluate at that point. So that's why we want to study limit in this class here. Substitution might not work anymore. Okay, it's not like a function where it is defined, you just substitute, you got the point, substitute. But this is different. Okay, so in fact, a substitution won't work, cannot work. That's why you need to think. Okay, right. Sometimes we also call this more generally, okay, including what we have see for the other two definition for this derivative. We call this instantaneous rate of change of f with respect to x. Okay, this is the most general form. Okay. Yeah. So if we want to add in a point, okay, fix at the point at x equals to x1, then really you need to write down at which point you base it. Okay. So the point here is these xi here, right? Fix some chosen point. Okay, these xi are some chosen point. Okay. Okay. Any question so far? So you imagine that if I change this xi at different xi, then the instantaneous rate of change could change. Or it could depend on the xi. And in our case here, our xi is just a. And in our case here, xi is a. In our case here, xi is a. So it depends on where you add. So you should imagine this picture here. Okay, imagine what A you take. You can see that these gradients are different. Some are steeper, some are less steeper. Okay, so in particular, when you get a larger A, okay, go to infinity or negative infinity, you will get very steep. Okay, so your gradient will be very large. But when you get close to 0, then you will get less steep. Does that make sense? Okay, so this number instantaneous rate here will depend on the axis you take. And that's why it's called instantaneous. Okay, it's not uniform across. Okay, it's not uniform. All right. So let's go to this derivative here. So if you look at this fx equal s squared here, so you can see that at every point of x, actually we can get this tangent line. We can get this tangent line. So once we get this tangent line, actually we also got the gradient. We got the derivative. So in that case here, every point will admit a derivative. So meaning what? I have a point, I output a derivative. I have a point, I output a derivative. What is this? This is another function. Okay, so derivative actually is a function. So let's go down here. Okay, so if I make the A general, then it becomes a function actually. Okay, so for example, if we want to compute what's the derivative of fx, fx equals to half here. So we just follow the same formula. We no longer use A anymore because it could be general. Okay, I just compute it at every point. Okay, so we compute it for any x in real number. If this limit here exists, then it becomes a function. So let's try one. I try once and then I let you try the other question. So for this one, I got 1 over x plus h minus 1 over x over h here. Okay, so if we simplify quickly, we should first get x minus h over xh over, and then multiply by x plus h. And then this will simplify down to minus 1 over x plus h equals to minus 1 over x. Okay. So I think most of your high school syllabus cover derivative, right? So if you apply your formula, do you get minus 1 over x squared? What's your formula, your high school? You'll bring your power to the front, right? and then minus 1 with the power. So do you really get minus 1 for x squared? Which is minus x to the negative 2. Okay. If you prefer the other form, maybe you could write like this. So this is minus x to the negative. Right. So you bring minus 1 down and then minus 1 minus 1. So you get minus 2. Okay. I give you 1 minute. Try and figure out what's the derivative for square root x, and then we can check answer together. Yeah, try do it. Yeah. Try to practice. Take this time to practice your calculation skill. Okay. Anyone got answer? What do you get? Square root x divided by 2x. I think it's close. It is you can simplify this, right? Yeah, so you could simplify it to 1 over 2 square root x. Okay, depend on what form you want, actually. Okay, so how to get this? So basically, you first put x plus h into your function, and then take away the original function, okay, and then divided by the h. Okay, so how to simplify this? So you got square root, right? Okay, you got the minus here. So first of all, you realize that if you substitute h, it won't work. Okay, it's not continuous. H equals 0. So the trick you can play on the radical or this root is you multiply by conjugate. Okay, so you could multiply by conjugate. Or by conjugate, I mean you replace the minus sign with the plus sign. And then you multiply on top and bottom so that you are doing nothing to the function. And then you can simplify it. I think the simplified form was 1 over square root x plus h plus square root x. So you can see some miracle here was, although dividing by h, right, you cannot just do substitution, but after some simplification of your function, usually this h will disappear. Okay, the h in the denominator will disappear. Then this make this limit possible. Okay, then this will make the limit possible. Okay, make sense? Okay, so when you do this kind of calculation, right, you will always hope that I can remove the h, okay, in the denominator. Okay, after some modification or something. Okay, so everyone happy with this calculation? Question? Okay. All right. So actually, for example, for these two examples, right, you can try use GeoGebra to plot out what is fx, what is f prime x. Okay. So for example, I did one here. So I did one here. Okay. So actually, I did two. So one of them from your textbook. So if you see that 1 over x is looks like this, okay, then you try and plot out all these gradient of these tangent line. Okay, then the function will stay at the bottom. Okay, it's always negative actually. Why is it always negative? Why is it always negative? If you look at these tangent line, right? Okay, you can see that it's in this direction actually. This is y equals to x or y equals to minus x shape. Y equals to x looks like what? Should stay on the first and the third quadrant. So if you are slanting on the other side, you should get a similar y equals to minus x shape. Okay, just changing in gradient. Make sense or not? Yes. So similarly, if you look at the gradient here, also in this direction. Okay, so that's why your derivative is negative always here. Make sense? Yeah. Okay. Try draw it. Your all your tangent line is similar to y equals to minus x. Okay, just with different scalar. Okay. 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 Next one in your textbook, you also have this. So this is another extreme. So if you look at all these tangent line, right, they are like the same shape as y equals to minus x. I mean shape meaning same direction. But it's always positive. So you can see that when x go to infinity, right, it get very close to horizontal line. What is the gradient of horizontal line? The gradient is 0. Okay, so that's why you see the gradient function here decrease is to almost go into 0. Okay. Like close to 0 is like shoot up, almost like a vertical line. Okay. All right. Yeah. So finally, we have this hard question to deal with. Hey, should we go here first? Not yet. I think we still got a little bit more. So we have a different notation for derivative. I think the most common one is dy over dx. Okay, you see before. And then the rate of change that we introduced just now. And then the middle one is the definition. And then this one, f prime x, is another way to write it down. And there are more definition here. Out of these definition, right, I prefer actually this one. Okay, I prefer this one. So if you write dy dx, do you think it is a fraction or not? Do you think it's a fraction? It's actually not quite a fraction. Okay, meaning you cannot like d over dx like slash slash like this. Okay, so you cannot do this, but it is true that d over dx of dx is 1. Okay, so you need to use the, what is the definition? You need to use your limit. Okay, you need to use the limit x plus h minus x over h, which is indeed 1. You understand? So that's why we suggest a fraction notation for it. But the reason of getting 1 is not by just factor cancelling. It's by limit computation. Okay, it's by a limit computation. Okay or not? Okay, so later you will see another instance that, oh, this dy dx, right, really behaves like a fraction. Yeah, but most of the time it's not. Okay, you should think of it as an operator. It's like the operator you learn in linear algebra. It's actually a linear operator. Okay, so it brings you from a function to a number. You input a function, compute a number. Okay or not? So a function is differentiable on a open interval if it is differentiable at every number in that interval. Okay, so where is this function differentiable? Okay, so we want to find, so the question is we want to find a, okay, such that the limit of h to 0 of of x plus h minus fx over h exists. Okay, we want to find all these points here. Okay. But recall that how do we define this modulus function? Yeah, how do we define it? Do you remember? Huh? Where do you get x? Where do you get minus x? Sorry? When x greater than 0, we take x. When x is less than or equal to 0, we get minus x. Okay, so what's the shape here? So once you write down this function, right, try to recall yourself what's the shape. So this is the V shape. Okay, if you get from, I mean, the definition of gradient, right, the limit of secant, right? Okay. Can you guess where the function differentiable and not differentiable? If you get the idea of the limit of secant of nearby secant. Hmm. Zero. Why? Left or what do you mean by left, right, or equal? What kind of limit? There's a lot of limit we can see here. So what's the left, right limit? You need to talk more. It's about the tangent. It's about the secant. Right. So if you form a nearby secant, right, it is the same all the time actually. Okay, on one side, what's this secant here? I mean, based on the definition, you should see that this line here should be y equals to x. Sorry, minus x. Okay, the other line is y equals to x. Okay, so if you take the limit, one is 1, one is minus 1. So they are not equal. Okay. Okay, so let me write down the full argument here. So for a that is less than or equal to 0, okay, so if you compute limit of h to 0 of f x fa plus h, sorry, here should be a, right? Okay, minus fa over h. So what's this? Because a is less than or equal to 0, so you can just use the definition of minus a plus h, and then minus a over h. So what's this? Minus a plus a is 0, so h over h is 1. Okay, so is it true? So we get minus h over h, sorry. So in the end, we just get minus 1. Okay, so similarly on the other side, you should get you should get a plus h minus a over h, which is 1. Okay. So at this point, they are okay, but there's a point it's not okay, which is when a equals to 0. Okay, so at a equals to 0, if we want to check the limit at this point here, we should check the left and right limit first. Okay, so if you check the right limit, the function you're gonna use is let me write down first here. So the function you're gonna use is the positive one, okay, which is a plus h minus a over h, okay, which is 1. But if you do the other direction, if your h, so one h is coming from the positive side, the other h is coming from the negative side, So if you do the negative side, the f you're going to use is the -1. Okay, so then you get -1. So left, right are not equal. So this example uses whatever you learned before, okay, to see that actually this function is continuous at, sorry, differentiable at any point that's not the origin. So let me see here. So since the left and right limit at a equals 0. Of this special function here, f of a plus h minus fa over h at a equals 0 are not equal. Its limit at a equals 0 does not exist. So if this limit doesn't exist, it means that f is not differentiable at x equals 0. Okay, or a, I mean, yeah. Okay, fx. So we are talking about fx here. So that's what we say. Okay, so altogether, f is differentiable at all points except 0. Okay, yeah. Any question so far? Question? Any question? Any question so far? Can get it? Okay. All right. Let's continue. So we reached the last part here. So actually, differentiability is kind of stronger than continuity here. So if x prime x exists, then f is actually continuous. Okay, so you can prove it. I think we won't do it here. Okay, so I will put the proof, but you can remember it. Okay, if you can't prove it. But the other one is not true. Okay, so if it is continuous, then it does not imply that it is differentiable. Okay, differentiability is stronger than continuity. Okay, so any differentiable function, if you want to do the limit computation, you also can just do the substitution way. Okay, because it's continuous. Okay, but if you can do the substitution property for your to compute your limits of your function, it doesn't imply that it is differentiable. Why? Because for differentiability, you actually compute a limit for a different function, right? So you require the limit of a different function to exist. Okay, so how can a function fail to be differentiable? For example, this corner here. Okay, I didn't tell you what's the formula for this corner, but if you see what's the limit of your secant here? Okay, you can see that actually it goes to infinity. Okay, so this kind of limit of secant cannot exist because go to infinity. Okay, so corner is not differentiable. Vertical tangent also, because this tangent also go to infinity with the gradient. Okay, everyone comfortable with a vertical tangent with a infinite gradient here? Is it okay? Because if you start with y equals to x, and then y equals to 2x, 3x, 4x, 1000, x million x, okay, so your gradients go to infinity. Can follow? Can or not? Do you guys know that how to compare y equals to x and y equals to 2x? Okay, so if the gradient get large, it gets steeper. Okay, once you get to vertical, then you can shoot out to infinity. The other point, of course, is discontinuity. Okay, if it is not continuous, then it's not differentiable. Actually, this is also a logic statement here. So if you have a statement like if P then Q, okay, so this is equivalent to if not Q, if not Q, then not P. Okay? These two are equivalent. For example, if I get a good result, I will treat myself a KFC. If I don't treat myself a KFC, that means I don't get a good result. True or not? Huh? What do you mean right now? Because if I get a good result, I will treat myself a KFC. So if you see that I don't treat myself a KFC, that's me I don't get a good. Because if I get a good result, I will treat myself a KFC. Okay, so this is a basic logic. You need to like fix your mind. Okay? Because if P happens, Q must happen. Okay? If Q doesn't happen, P cannot happen. Because if P happens, Q must happen. P and not P cannot happen together. Q and not Q cannot happen. Otherwise, we got a contradiction. So you need to turn your mind a bit. Don't be confused. Because I understand that. I mean, I'm not sure about other country, but maybe I can represent Asian. Okay, I grew up in an Asian family. So in an Asian family, right, usually what parents say are correct, even though there are contradictions. So the child easily get confused, actually. They get pretty confused. I thought you said cannot do just now, but now you say can do. Okay lah, can do lah. I thought you said can do, but why cannot do now? You said cannot, okay, cannot. So you need to switch your mind, okay? You need to understand the contradiction. What can do, what cannot do, and then under what condition can do, under what condition can. Okay, because now you are grown up person, you should decide, you should make decision. Okay, because maybe your parents didn't go through this kind of systematic logic thinking. They maybe also inherit this kind of contradiction from the previous generation. Okay, so since they give you a chance, okay, to do education here, you should kind of fix your mind and then help your family. Actually, okay, you should help your family. Okay, 9:99. Okay, we still have a little bit more, and then we maybe can take an early break from here before we go to the next chapter. So you can think that, oh, I do once, and then f prime x become a function. Can I do again? Can I do a derivative of f prime again? You can. So this is how we define a higher order. So you can keep doing it, okay, multiple times. As long as you can do it, you just continue and do it. Okay, so we'll get a higher order of derivative. So if you find the derivative of f prime, you'll get f prime prime, which is the second derivative. So if f prime prime is a function, then you can again differentiate it again. You get f triple prime derivative, and then so on. And then we get such that we get n derivative. Okay, so if you look at this one here, I left as a homework. Do you know how many times you can do derivative here? I mean non-trivial derivative. Can you guess? Two. So you do once, you reduce the power because from what you have learned before. But I suggest you to use the limit way to compute it. So you do it once, you decrease 1 degree, and then you do it twice, you decrease your degree until constant. Okay, and then the rest you will always just get 0. Okay, yeah, I suggest you use the limit way to compute, because soon after you will forget this limit method already, because we will use a lot of formula. So use the limit way to see actually f and x is 0 when you do for n greater than 2. Okay, you always get 0 already. Okay, So these are the notation you will see in the textbook or in future or in your computer science course. These are the and either you use the f prime notation, or even you also can use the y prime notation, or you use the big D, capital D notation. Or the last one, the dy dx is called the lightness notation. So in the lightness notation, you see this D is it this 4 is placed in a different how to say on a different place. So what do I mean by different? One of them I place on D. So on the numerator I place on D, on the denominator we place on the variable. Okay. So this one actually suggests that d over dx is really not a fraction. If it's a fraction, I can put n on this y. So this notation here actually suggests that dy dx is not exactly the fraction. Okay. So you should really think of this notation as d over dx on some function like that. Okay. This is a proper way to write it, so that you don't confuse yourself. Okay, any question so far? Question? Before we go to next chapter. Any question? So far we have finished function, limit, or limit. We see that some function has a substitution property when you compute the limit. These are the continuous function. And then from continuous function, we look at the changes of the tangent line. Again, in particular, the gradient of the tangent line. So these constitute the derivative. And if the derivative exists, then we will say that this function will differentiable. Okay, where the derivative exists. Okay, so far. Okay, let's go a bit further and then we will take a break. Okay, so finish the notes. I should bring this note out. It's this blackboard. Okay, so for this chapter, we will go through all the differentiation rules. Hopefully, you have seen it in high school. Can I see how many of you seen this kind of rule in high school before? Only 2, 3, 4 only. Where are the China students? Do you guys see it or not? Also see. Okay, so hopefully we can go faster in this chapter. I guess most of you already seen it. Okay, so by whatever you learned just now, can you decide why d over dx on the constant function is 0 by whatever you learned just now? So you compute the limit, right, of the changes in x, right, changes in the value on the changes in x, and then divided by the change in x. Okay, but your function now is c. So no matter what point you put into it, it is still c. Okay, so c minus c over h, what is it? 0. So you are looking for a limit of a 0 function, which is 0. Okay, so that's why you differentiate a constant function, you get 0. Okay, similarly, all the rest that we discuss later, you can prove it by using limit, but it's not very important for this course for now. Okay, so similarly, you can prove that d over dx is 1. Okay, use the limit where I think just now I show it to you. And then the other important one is this power rule, right? You can bring the power down and then take the power minus 1. Okay. And then for now, for the moment now, the n we will just restrict to positive integer first. For the rest, you need to prove it differently, so it will be a different statement. Okay, so I text here. If you want to practice your limit calculation, you can do it. But otherwise, it's not too important, this proof. So I would say that this proof might not be I don't think it will get tested. If they get tested, we will inform you first. Okay, so you see, then a harder way to prove is this power rule here. You can generalize this n to a different real number, not just positive integer. Okay, because if it is a positive integer, you can use the something like the binomial expansion. Okay, but in general, it's harder to prove. Similarly, this rules here will suggest why derivative. I mean, this differential is a operator. Okay, because if you differentiate on CFX, then you can actually pull the C out. Okay, I think there's something missing in this condition here. You guys can recognize or not what condition is missing here? There are conditions missing here, I think. Can you recognize? When can you do all these? What do you think? If your d over dx fx doesn't exist, you can do or not? Cannot, right? So actually, you need to suppose that f and g are differentiable. Okay, it's like the limit law, continuous law. Okay, you need to assume your individual function has limit first, or they are continuous first. Only you can do this splitting. So differentiation actually is linear because if you differentiate on a c of a differentiable function, you time and the derivative. If you compute the derivative of the sum of two differentiable functions, you could just add the derivative of the two functions. Is it convenient? Okay. Otherwise, you need to do the limit thingy on the sum function or the scalar product function. Okay. So this is very convenient. So there's a proof here. Okay. If you want to go through, you could. Actually, these proofs are very elementary. Okay. So you can use limit law to prove it in particular. Okay. So how about let's try two examples and then we can finish for this hour. Okay, so let's try one for you, yeah. So you can see that by part A here is a sum of what? Sum of differentiable function y. Minus 6 is differentiable because it's constant. 7x is differentiable because it's a scalar time a differentiable function x because dx over dx is 1. And then 5x squared, you can use the power rule. Okay, you can use the power rule. So if you can state all these rules, you are a good student here. Okay, so if you can state all these rules you use, then you are good here. Okay, so in general, you can split this derivative into like differentiating 5x squared plus differentiating 7x plus differentiating minus 6. Okay, this is the linear rule number 2. Okay, and then you can pull out the scalar. So maybe you might think that it's a bit troublesome to do step by step, but this is the very good way to make sure you know what you are applying. Okay, because in particular, you guys do coding, right? You guys do coding. Yeah. So I actually hate coding a lot. You know why I hate coding a lot? Because my eyesight is not good. Because if you have a little slight, maybe punctuation, comma, gone, then you don't know where it happens, right? Right? It's very hard to find this small little detail. So it's better that you state this small little detail from the start. Then you are easy to check. Okay. In particular, I think I saw someone, they will like comment their code. Like for this part of code, what are we doing this part? Then we can easily backtrack it. Okay, so for this, in this case here, if you apply the power rules, right? For the first one, you will get 2x, 5 times 2x. And then for the other one, you just get 7 times 1, which is 10x plus 7. Okay, okay, maybe how about B? Okay, I will leave it as a homework, but can you, from your inspection, from your eyes inspection, can you tell me your answer or not? 4x to the power 5. Okay, then minus 50 over x4, and then minus 20x plus 5. Okay, good. At least basic calculation you can do. But please write down the step, okay, to make sure you know what you are doing. Okay, so your homework is fill in the step. Okay, question for now? You okay? Okay, let's break until 10:01. Yes.
What is the difference between using this and doing it normally?
What do you mean normally?
Like that one. Like just
That
give it
one
the-
is after we do this and then we got the formula like this. So you see, what's the difference of doing this and this, right? This is your question.
Mm.
So doing this is formula. So where does formula come from? From here. You understand? You don't understand? Wait, let me think. So what's the problem here? Okay, you repeat your question.
What is exactly the difference between
Hmm.
using this and then just converting this immediately into that form?
You mean this power rule?
Yeah, the power.
Yeah, so okay, good. So actually the starting point of derivatives is here. Without this one, this is nothing. Like, don't know where this comes from. Why we got this kind of rule? Exactly because of this kind of calculation. So you can imagine about this. So why differentiate C is 0? Because of this limit computation. So this is the root.
Mm.
Yeah, okay or not?
Okay.
Only after this calculation, we know that it's always true, then we write down this formula. It makes sense or not? I mean, like, this is not the starting point. The starting point is this.
If
Yeah.
when eventually if eventually there's a quiz about this.
Sorry?
If eventually there's a quiz about this, do I have to write from here or can I just use the power?
I see. I think we will specify. If we want you to compute using limit, then we will say it.
Oh.
Yeah, I think, yeah. We will say it when we want to use it.
Thank you.
Okay? Yes. Yeah, sure.
就是尝试这种那个路演 X 法3分之1，
对，
但是这个东西，其实它是一个定义，但是不太理解，就是因为当时他们也是直接给出来的。
哦，你说这个怎么算出来的？
对对对，它为什么等于
课本有，
需要解释？
课本有，你可以去看课本。应该我们在班上，我不确定我们会不会去做给你看，但是课本有。如果你要先看，你可以去找课本，课本有解释这个。OK 吗
课本是那个
？Stewart，那本 Stewart，
就是贴在那个课程。
对，他作者是 Stewart。你要 print both side。OK。哎，你要去拿一下，在第二辆。第二辆就是在那个放纸的隔壁那个。我现在 print。如果 print 不能，你再跟我讲啊。是了。
是哦。
OK。如果你 print 不到，你再找我。OK。 Let's take the attendance for those who are here. First, 常熙和乐天、瑞阳、若石、石曼、一南、一南、一南、玉涛、陈玉涛，OK，一泽、丽文、戴丽文，OK，瑞阳、泽汉、嘉来、嘉诚、和嘉诚、吴嘉怡，OK，齐军、易清、俊逸、相思，OK，一林、雷印，OK，冰真、李冰，OK，嘉团、浩云、李浩云、林浩云，sorry，浩云、文琪、汉翔、俊杰，OK，新阳、卢旺达，I think I saw you，OK，新月、玉恒、马玉恒，所以 not 马一很多玉恒啊，OK，马一田 went to toilet. Is he here last Wednesday? I mean Wednesday here. Okay. 苗冰城、倪浩然 Desmond、Tommy. Okay. 琼毅、卢琼毅，英杰呢？Okay. Gopagani. After. Okay. Isham. Wait, I missed someone. Arianto. Daniel at the back. Huh? Oh, Daniel is sick. Oh, sure. Today. Okay. Tired. Sick. Flu. Fever. Okay. He's Hasim. Nadia. Got. Aaron. Brenda. Felicia. Gunakati. Margaret. The back. Hassan Khalid. Okay. Hassan Khalid. Good. Jahil. Javed. Yeah. Gabriel. Run. Jeffrey. Purity. Yeah. Chen Fan. Okay. He Yating. Disappear. Hu Ye. Oh, here as well. Guo Hongling. Oh, okay, you are here. Yeah, everyone back from toilet that I haven't paid your attendance. I think I took yours. Okay. So your friends asked a question, yeah. So when do we use the product formula, or I mean the power rules, or should we use this limit calculation during exam? What do you think? What do you think? If you are lecturer, what do you think? Okay, so just now I taught you, right? You can just use the power rule to get this. Okay, I also teach you how to use limit to compute. So which one you should write down in exam? If you're a lecturer, what do you think? Sorry? So there are two methods to compute the derivative of fx now. You can use formula or you can use this limit. You use formula, you prefer formula. If you're a lecturer, you prefer. How about all of you? You also like formula. Okay. Okay, so in general, you just use formula, okay? Unless we say by limit computation. Okay, from the definition using limit, then you need to use limit. Okay, so if there's no mention, you just compute. Okay, clear? Okay. Okay, let's continue with a bunch of formula. So for C, how should you modify this function to make it computable for C? What do you think? Is it a better way to write down this function so that you can differentiate it? X plus over x. Yeah, okay. Then you can realize that the derivative of x and 1 over x exists, and then you can do the linear formula. How about this one? Can you do similar thing? Yes. Okay, so you can do square root x plus 1 over square root x. And then square root x is differentiable using power rule. Second one also using power rule is differentiable. So the sum of them is differentiable. Okay, so you can do it. Okay, so I suggest you go back and do it. I won't do it together with you for all these, because they are similar. Uh, for this kind of question, what do you think you should do? I think we see this kind of question before. Right. So now we want to find a point on the curve such that the tangent line is horizontal. So what do you mean by that? So what are these points where tangent line is horizontal? So what does it mean by horizontal tangent line? So this is the key point we need to digest. Because dy dx you should know how to compute already. Very simple, the polynomial. But what's the condition about horizontal tangent line? This is equivalent to what? What does this tell you about its derivative? Huh? Dy dx have to be? Yeah, so my dy dx should be what? To satisfy what? Horizontal line. Huh? What's your gradient of the horizontal line? Huh? 0. Okay, horizontal line. So one thing you need to remember is horizontal line has gradient 0. Okay, so dy dx is the gradient of the tangent line. So we want the dy dx to be 0. So you need to solve this. Okay, if we quickly write down was, so you need to do some steps. So then if you do it, here is for x cubed. So you need to find x such that for x cubed minus 6x equals to 0. Okay, you solve this. Okay, I won't write down the full step. The full step will be written in the lecture note. Okay, so please check the lecture note. So now we will just discuss what's the general strategy to solve it. Okay, everyone happy or not? 3.2. You know how to continue from here? Can you just find the root? Okay, for this function here. After you finding the x, you should find your y as well, because they are asking the point on the curve. So you need the xy coordinate. Okay, after you find the x, you should find your y as well. Right. For this one, do you know what to do here? I gave you equation of motion. So it's like a displacement of a particle. It moves like a cubic polynomial. Then you want to find the acceleration. What should you do? So x is the displacement. So go down next step. What do you want? Velocity. So velocity is ds over dt. And then what is acceleration? Acceleration. The change of velocity. Okay, so it's another change. So you should acceleration. You should do so let's call this velocity v. Okay, let's call it v. So actually you want to find dv over dt. So let's call this a. And then at the same time, this is d over dt on dx over dt. Okay, which is d square x over dt square. So you do the differentiate twice. So you can you imagine you start with a qubit, you differentiate once, you become a quadratic, you differentiate again, become a linear function. Okay, so your acceleration is a linear function. So if the question asks about acceleration after 2 seconds, what should you do? At the 2 second, you put t equals to 2 into the last one. Okay, makes sense? So in the end, you should do this. So you evaluate. So this is what we call evaluate at t equal to 2. Okay. Okay, so let's skip this. Please go back and do, yeah. I will put out the solution. Good check. All right, I think we should discuss this. So let's figure out what's the derivative of an exponential function. So just use the limit formula, yeah. So f prime x is what? Limit of x to 0, and then b to the x plus h. Take away the original function divided by the change in x. So can you realize that? What can you realize? Bx actually is a fixed number. Okay, so we can pull this x out. Okay, and then we just look at this bh minus 1 over h. Okay. So seems a bit complicated, but let's say if I fix my point at 0, so what happened at f prime 0 here? Okay, this limit here is basically just bh minus 1 over h. So this is very nice. Okay, so what I mean by very nice here, it means that if this limit exists, then at all points, this limit also exists, right? Then you could just multiply this limit to your bx. That's it. Okay, so the point here is if f is differentiable at 0, so meaning that limit exists, then it is differentiable everywhere. It's very convenient. So we just need to decide whether it is differentiable or not. Okay, at 0. Okay. And if we know that, then f prime x is just f prime 0 times bx. So we replace this part here by the derivative at 0 of f at 0. Okay, so we kind of like, if we know what happened at 0, then we will know what happened at every place, just by multiplying by b to that. Okay, it's kind of amazing here. Okay, but if you realize that if what happened when b equals to e, okay, meaning you look at this exponential function here. If you still remember last time we talked about the specialty of this function, right? The tangent line, okay, you find at the 0, what is it? The gradient is 1. Okay, so meaning this limit here actually is 1. This is when this is how we define E last time. e to the x last time. Okay. But for the other kind of b, not sure what is it. Okay, not quite sure yet. Okay. Does it make sense? Okay, does it make sense? Okay, for other b, we're not sure yet. But at least for e, we know. Okay, based on what we defined last time. Okay. So last time we defined this dy dx here is 1. So then if this limit is always 1, right? Then this will tells you that d over dx on ex is just ex itself. Okay, so that part disappear as 1. Okay, it's not disappear, but it becomes 1. But for arbitrary b, we will do it later. Okay, so we just know when b equals to e for now. So that's why you differentiate ex is always ex. So what does this mean? So this means that if you start with ex and then you draw the tangent line, you compute the gradient, it still looks like that. Still the graph looks like so. Okay or not? Okay. So let's say you have this 3.4 question here. What should you do? At what point on the curve y equals to ex is the tangent line parallel to the line of y equals to 2x? So let's draw this condition first. So I hope that in this class you learn how to draw, okay, not just computation, because drawing will really help your understanding a lot. Okay, so y equals to 2x is like this. So do you know what's this question asking here? So it asking that which tangent line is parallel to this line? Okay, so meaning which tangent line is slanted the same way as this function. So where is it? Where is it? Okay, so where is it? Okay, so to do this, what do you need to do? What do you think? So tangent line parallel to the line y equals to x is equivalent to finding what? So you need to, in this class, there's one technique you need to learn is you need to learn how to make your real life problem into a question that you can solve in calculus. And so what does it mean by parallel to this line? So what can you tell me about the gradient of this tangent line? What's the gradient? 2. Okay. So the gradient of this tangent line should be equals to the gradient of y. Should be equal to the gradient of y equals 2x. Okay, which is 2. Okay or not? Okay. And then do you know how to make the line? Do you know how to make the line? So you need to find what's the x that satisfy e to the x equals to 2. Okay, you find x and then you find y. Okay, so find x and then y and then make the tangent line. Okay. Any question? We make tangent line before, so we won't repeat it again. So try and do it yourself. Or do you still have question how to make tangent line? No question? Yes or no? Do you want to ask what's the question? How to make the tangent line? Okay, so to make a tangent line, what's the line equation? Okay, so one thing you should remember here is the line equation. Okay, what's the ingredient you need for line equation? You need a gradient. I mean, like, how do you build out the line? You need to tell me how you build out a line. 2 things you need only. You need a point on this line and then you need tell me the direction. That's all. I know this line already. Correct or not? I got the point, I got direction, then I can form the line already. So this is the 2 ingredient you need. Okay, let's call this x1, y1. Okay. What's the gradient? Then this direction will be given by the gradient. Okay, and then the formula is just depend on how you write it. I think I prefer this form. Y minus y1 over x minus x1 equals to m. Maybe your friend can tell you that y equals to m times x minus x1 plus y1, but it's the same thing actually. Hey, where's your friend? Where's your friend? Competition? Oh, okay, okay. I think so. I think so. I got the few sending me the email. I cannot remember who is who. Yeah. Okay. Okay. Yeah. So I mean, depend on which one you prefer. Lah. Okay. I prefer the first one. Do you know why I prefer the first one? This is exactly telling you where you get your gradient from. It's the change in y over the change in x. Yeah, but I think in most of your high school textbook or any textbook, right, this because this will tell you why, how you get y, how you get y. So that's why they have the check. But really, it's just a ratio. Okay. Okay. So you find your xy and then you plug in this formula because you already know your gradient, right? In this case, is 2. And then you just need to find your x1, x2, y1, x1, x1, y1. Okay, any other question? No? Okay. Very straightforward. Please go back and do. Yeah. All right. Uh, let's go to the product rule and quotient rule. Can we verify this quickly? Again, let's verify this quickly. So you might think that, oh, limit work for products or functions. Continuity also work for product or function. But differentiability works for product or function. So meaning, if I differentiate a product, does it equal to the product of derivative? Okay, so we use this example to show that it is not true. Okay, so let's see on what side, what do you get? On one side, you get a derivative of x cubed, which is 3x squared. But on the other side, d over dx on x and d over dx on x squared is 1 times 2x, which is 2x. Okay, much less. Okay, on one side is much less. Much less. So there's something missing here. So we need to put those missing parts into it. So how we put it is using this way. This d over dx of uv is u times dv over dx plus du over dx times v. Okay, this is how we add in the missing part. Okay, so one way to remember, I think, is this. I think I memorized this very well. uv prime equals to uv prime plus. The direction doesn't matter because it's an addition here. There's no sign problem. So the point here is you need to take one of the original function, multiply by the other derivative, and do it the same way for the other way around, and then add them together. Okay, make sense? Yeah, because the other one is u prime v, so you keep v in it. Okay, so you should imagine that, oh, there are derivative sign here, right? I should do it. I should be able to do it using the limit way. Yes, true. Actually, this is proven using the limit way. Okay, so it's in the textbook. We won't test it. This is a bit harder, but I think for some of you, you should be able to appreciate it. Okay, let's do this. Okay, let's do this. Which one we do first? Let's do expansion first. Okay, let's do expansion first. And then I'll let you try product rule. See if you can succeed with your product rule. Let's try expansion first. So if you expand it, you should get 4 terms. So first term is 6x to 6. Then second term, you open the bracket. So you get minus 3x cubed. Then the third term, you get minus 10x to the 4. And last one, you get 5x. Okay. So if you go through all the power rules, sum rule, scalar rule, okay, the linearity of this differentiation operator here. So we will get 36. Am I doing something wrong now? 3, I think correct. 36 to the x plus 5, and then 9 to the x plus 2, minus 40x. Am I correct? Yeah. Everyone can check. I'll check. Is it true or not? True. Correct. Okay. Okay. What? Yeah. Where? Which part? Minus 48. Where is the 48? Minus 40. Oh, cube. Cube. All right, sure. Thank you. So minus 40 cube. Okay. Other than that, okay. Okay. In that case, try and use product rule and then compute it. Okay. So now your u is 3x squared minus 5, and then v is 2x4 minus x. Okay. So try and use the formula. So dy dx is equals to uv prime, u times v prime equals to u prime v plus v prime u. Okay, I give you 1 minute. I mean 1 minute a bit. Try and compute this. Let's check if you get the same thing or not. Okay, so if you take u prime first, right, what do you get? 6x. And then if you take v prime, you should get 8x cubed minus 1. And then you just do the multiplication. 6x times x cubed minus 1. On one side. And then on the other side, you get 8x cubed minus 1. Wait, v is not this one, v is this one. Then v prime u is this. Okay, so if you expand everything out, you should get 12x power 5 minus 6x squared. And then plus 84, 24, x5 minus 40 x cubed minus 3x squared plus 5. Okay, so let's check. You got a plus 5, plus 5, plus 5 here. And then you get the 36 x over 5. And then you get minus 9 squared. And then you get minus 48. Okay, so we really tally up the solution. Okay. So let me ask you a question. So in reality, which one you use? The expansion method or the product rule? You use expansion. Others, eh? Others, eh? I only hear voice from Indonesia. How about China student? What do you think? Sorry, you don't have an opinion. Which one you prefer? Which one you prefer? Expansion or product rule? 你懂我讲多吗？ Which one you prefer? Very good. Good. This is a very good answer. It depends on the situation. Because in this case, it's polynomial. Maybe it's easier to do exponential. But if it's not polynomial, it's a very hard product. Then maybe product rule is easier because you just need to differentiate individual factors. Okay. Yeah, it's really depending. So you need to learn both. Okay. So that you can decide what you want to do in real life. And actually, this is very true for education. Why are you studying? To give yourself a choice. You are earning choice now. If you don't learn, you have no choice. Because you don't know. Then people ask you to do what you just do. You have no choice. But since you are learning now, you can make your own. Then actually, all of us are actually fighting for freedom. Okay, freedom. Right. Okay, so how about 3.7? Yeah. How to do this? So can you realize that fx is a product of function? Product of what? Product of two basic function, right? One of them is x, the other is e to the x. Okay, so if you want to differentiate, what can you do? You use your product rules. Okay, so what's your product rules? You keep one, differentiate one, and then plus doing the other way around, you differentiate the first one and then keep the second one like that. Okay, so what do you get? X e to the x plus 1 time e to the x. Make sense? Okay, how about the next one? B. How about B? So what this question asking n? N is general, right? So meaning what? Okay, so well, so there's a implicit meaning here. So this n here, right, is actually the natural number. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how to see n here? So you need to start with 2, 3, 4, 5, 6, and then see what's the pattern. Okay. So 1, we already did the pattern. How about 2? Can you see what happens to 2? Huh? You are differentiating e to the x plus ex, right? Okay, but you know that you can differentiate x times e to the x and ex. So it is just x to the ex prime plus ex prime like that. Okay. But do you still need to use product rule again? No need, we already compute in part 1 already. So we get x to the e to the x plus e to the x, and then the other part we still get e to the x. Can you imagine what happened to the e to the third derivative? Can you imagine what happened? Can you imagine? So similarly, you can get x to the e to the x prime plus e to the x prime plus e to the x prime. So in the end, what do you get? You repeat inductive x to the ex plus ex plus ex plus ex. Can see formula now? What's the formula? You will get more ex, but you know exactly how many ex you get. How many ex you get? Every time you differentiate, it drop 1 ex. Okay, so in general, f to the n x, okay, differentiate n time, you get x to the ex plus n times ex. Okay or not? This is the formula. This is not quite a proof, but for now we will accept it. When you go discrete mathematics, you will learn something called induction proof. Okay? In that way, it will be more rigorous. Okay, so far, any question? Any questions so far? Clear? No? Okay. Right. How about next one? I think this one is also obvious, right? What's the, let's decide what's the u and v, and then I will leave the calculation for you. What's the u and v here? To compute this derivative. U you set as what? Square root t. V leh? A plus bt. What is AB? It doesn't say what is AB, or what do you think? Do you know what's AB? Yes, AB is some constant. Supposingly, they should tell you. I will add this problem properly later. Okay, otherwise it's otherwise if it is a variable, this is a 3-variable function. You will see this kind of function in calculus. Okay, so AB should be in real number. Okay, so I leave this for you to compute, yeah? How about this one? You know what do you need to do for this? So you write f as a product of function, yeah? So what's the product of function here? What's your u and what's your v? U is what? What do you think? Hey? What's your u, what's your v for this question? Don't know. Don't know. So you know how to read this function? Well, this is equals to square root x bracket times gx. Okay or not? Yeah. Okay, now better. So what is u? Square root x. V is gx. Okay, so if we're gonna use product rule, what happened? So from product rule, right, you really should know whether square root s is differentiable or not, and gx is differentiable or not. So I think this question is missing one assumption. You know what assumption is missing? This question is missing one assumption. We know that square root s is differentiable. How about g? Okay, we don't know. So actually, we have to assume that g is differentiable. Okay. At least at this point, at least at x equals to 4. Okay. All right. So if we're gonna use product rule, actually, it has to be differentiable there. So by product rule, what do you get here? So we get that fx equals to square root x prime times gx plus square root x times g prime x. Okay, which is 1 over 2 square root x times gx plus square root x times g prime x. Okay, so now the question asks you to find f prime 4. So you substitute 4 to every x. So that's why the question tell you what is g4 and g prime 4. Because it doesn't give you what is gx. You cannot compute. So you can only know how to check the value on x. Okay. If this question only restrict to s equals to 4, right? Then this product rule only apply at x equals to 4. Okay. Does it make sense? Does it make sense? Okay. All right. So this actually tells you that the product rule actually work on as a function. Okay, it's as a function, not really as a formula, because unless it's defined for x. Okay, everyone, so far so good for product rules. Question? Got question? You know what to continue? You can continue yourself, right? Okay, so you just substitute x equals to 4. Okay. Okay, next quotient rule. Okay, so let's say, how about this? So this is a little bit, this is kind of an extension from product rule. Can you see that? If you want to differentiate u over v, right, it's equivalent to differentiate u times 1 over v actually. Okay, so you can actually derive quotient rule from the product rule actually. Okay? But the formula was you start with the denominator, okay, multiplied by the derivative of the numerator, and then minus the numerator by the derivative of the denominator, divided by v squared. Okay, the order here is sensitive, it's not like product rule because you have a minus sign here. Imagine if you swap the order, then you will get the negative of the rule. Okay, so the order here is pretty important. So you start with v, start with the denominator, okay, and then multiply with the derivative of the numerator. Okay, so how about I give you 2 minutes to compute this? Let's see if you get the same answer. That's mine. Okay, I try and compute this. Try and practice. So since there's a division here, right? Obviously, you want the denominator not to be 0 so that you can apply this formula. This is the golden rule, okay, whenever your formula involves a denominator. Okay, someone done? What do you get? What do you get? Someone shout out your answer. What's your answer? Done here? Done? Shout. Oh, maybe you want first? Okay. No, at the back. Okay, maybe Arthur, right? Are you Arthur? Okay. You can shout your answer. Yes, shout out. Minus 21 minus 3x squared and then plus 10x over x squared plus 7 squared. Everyone got this? Everyone got this? Okay, good. Okay. So basically, what's your u? U is 3x minus 5. V, x squared plus 7. Okay, and then u prime is 3, and then v is 2x. Okay, and then you do your formula. So what's your formula here? Let's write down. So you take v, x squared plus 7, and then multiply by the u prime, and then take away u, take away 3x plus 5, minus 5, sorry, multiply by 2x over x squared plus 7 squared. Okay, thank you. Thank you, Arthur. I think I got the same answer. And then you do the simplification. Okay, quite straightforward, yeah? Okay, next. Find the equation of the tangent line to the curve y at a point. Can we skip this? No one. What do you mean? You want to check answer? I also don't have answer here. But do you know what to do here? Tell me what to do first. What's the recipe for this question? What's the recipe? First step, what do you do? Hi, Margaret, try. Here. Too far, you see, too far. Okay, so find the gradient. So these are the gradient for the tangent line, right? So you can see that why we place this question in this chapter, in this section, because when you want to find dy dx, this is involving a quotient. So you can use quotient rule. Okay, and then you want to find the gradient of the tangent line, and then Yeah, so you basically what you do is you find the line equation. So set up line equation using number one and your point. Right. Okay. Make sense, huh? Try and do this, huh? Okay, try and do this yourself. So this tangent line here, you should evaluate at the point 1 and e to the 2. You should think of why we pick this point, you know. Why we pick 1 and e over 2. Because hopefully, okay, your calculations should be easier, okay, when you compute the gradient. Okay. All right. Any other question? I think we find tangent line for a few times already. Yeah, okay. All right, go to the next section. These two we won't ask you to derive, so you can just remember. So how to remember this actually? So what does it mean by these two limit here? So first we have limit of sine theta over theta where theta goes to 0 is 1. So what does this mean here? So sine theta, there's a graph, right? Okay, so there's a graph of sine theta. So let's draw it. In fact, let's zoom it to theta equals to 1. Okay, let's zoom it to theta equals to 1 here. So by zooming it, is I look at this. Okay, but how about y equals to theta map here? So y equals to theta map is just the linear one. Okay, so maybe I use the full stop like that. Okay, so the point here is these two curves are the same. Okay, when theta equals 0, near theta equals 0, they are the same. Can you see from this graph here, they are the same? They almost touch. Okay, but away from theta it could be very different. Yes, makes sense? Yeah. So similarly, you can infer from B. Okay, so you plot 1 minus cos theta. So you got a cos theta, invert it, and then plus 1. Okay, then this is similar to theta. Can you imagine what is 1 minus cos theta? Imagine. Okay, so you start with cos, okay, and then you invert it, and then you plus 1. So you 1 minus cos theta like this. Okay. And then your is it? I think I'm right. You shift out 1. Yeah. Okay. And then you compare with theta. Okay, you compare with theta as well. But you get 0 in this case. I think get 0 makes sense, right? Because the numerator is going to 0. Yeah. But the point here is if you substitute 0 into it, right, it's like 0 over 0. Okay, usually undefined. So what happens here? Do you know what happens? Actually, this suggests some analysis of this two graph. Maybe I draw more, exaggerate a bit. Okay, what happened at 0? Actually, like this. Whoa, like this. Okay, so what does it mean? 0 over 0 usually undefined, right? I don't know which one go faster. But in this case, the numerator should go faster than the bottom. Okay, so that it can suppress the numerator. You understand what I say? No? You don't understand? Okay, see from the graph. Can you see that so this graph is y equals to 1 minus cos theta. Can you see that this 1 minus cos theta get to 0 faster than y equals to theta? Can you see or not? Can see this value here get very close to theta. Sorry, to 0 when theta goes to 0. So here is so let me label. So here is theta. Here's okay. Can see this part. This part. Okay. This part is much lower than the purple part. You know, so the numerator get to 0 very fast. Faster than the y equals to. Okay. Otherwise, if they go to 0/0, they are like cancelling out. Maybe they get 1 or yeah. Okay, makes sense. Question? Got question? I mean, this is like an informal way to tell you lah. Otherwise, you really need to use definition to prove it. Okay, this is the observation we make. Okay, from this formula. Okay, everyone happy? So actually, I think the most important one is the first one. Sine theta over theta when theta goes to 0, it is 1. Okay, they are almost the same. You see, they are almost the same. Near theta. Okay, so it means that if you zoom in like that, they are actually the same. Okay, if you zoom very big, they are the same. You cannot differentiate these two. Okay, they are the same. But if you zoom out, they are different. Okay. All right. So let's use the limit to find this guy here. Okay. So let's finish 3 examples and then we can take a break. So what to do, huh? The question say you need to have the same theta. Now one is 3x, one is x. Can you do anything to make them the same or not? 3x seems like you cannot put it up, but I think you can create something, right? So if you're gonna use the formula, you should have the same theta. Okay. Can we make up 3x or not at the bottom? Do you have any way to make up 3x? Multiply by 3x. Top and bottom, right? Because you cannot just simply get the 3x in, get the 3 in particular. Okay, so you just multiply top and bottom by 3. Okay. And then just now it's theta going to 0, right? So there's a hack here I think you can learn. So when x go to 0, 3x also go to 0. Okay, so we can replace the x by 3x. Okay, so then we can use the limit law just now. Okay. Can sorry, what did I do? 3x go to 0, right? Yeah. We change the variable. Okay. Yes.
How it's called?
Sorry?
How called? Like second something.
Second?
This row how called?
Which root? You mean this?
Like sinus over
Oh,
equals 1.
you mean this rule? This rule, any name for it?
Like have name.
What is the name?
In my language like
Perfect limit.
Yeah.
I never heard of it.
like
I never. Okay.
have a name. I think
Oh. Oh, I see. Where are you from again? Kazakhstan. Oh, so you got a name in your language.
in my
Russian language. Yeah, I guess Russian is more advanced in this kind of analysis. Actually, analysis advanced from Russian. So they have a lot of technique. But based on what I have learned, I don't know, I'm not aware of any name. Yeah, but we just call it some special trigonometry limit. Well, I mean, like, if you're using it, then I will know that you are using it. So that's fine, I think. Okay. Yeah. Okay, so in this case here, since we know that the limit of sine 3x over 3x exists when we take 3x go to 0, which is just 1. So we can pull the scalar out, then we get 3. Okay. Happy? Question? No question? No. Okay, so this is a variant of the special trigo limits. Should we do one more? Let's do one more. Let's do one more here. Okay. How about this one? This involves 1 minus cos t, right? So if you're gonna use the special limit, what you need for this? What do you think? You need an extra t in your denominator. So to create this extra t, you need to cancel it as well. So you need to put the 2 I mean t over t into your expression. Okay. So now are you happier? What do you think? Are you happier with this? Huh? Happy or not? Why happy? Huh? You know the limit of 1 minus cos t over t? How about t over sine t? Do you know or not? You know t over sine t? 1. Why is it 1? I mean, why? I didn't teach you t over sine t, right? So what's the connection? Yes, so you can write t over sine t to be equals to 1 over sine t over t. Yeah. So this is the step you need to write down. Please don't jump. If you jump, then your classmate don't know what are you doing. Okay. So you need to make sure everyone know what you do. Okay. So the limit of these two factor here, we know, so that we can use the limit law to spread it out. Okay. We can use limit law. So I can use limit law to split it. So 1 over sine t over t times limit t to the 0, 1 minus cos t over t, like that. Okay, so on one side you get 1 over 1, on one side you get 0, you get 0. Okay, last one, can we quickly discuss this? And I leave you to write down the details. So if you want to relate to the two identity, what should you do? Huh? What do you need for sine 4x to use the limit? You need a 4x, right? Okay, so on one side, you get 4x over tangent x. Okay, how to deal with 4x over tangent x? What do you think? Any idea? Split it again. Try and split it. Whenever you see tangent, we always want to see in the sine and cos form one. Okay, so write down the sine and cos form. So what do you get? You get sine x and then cos x here. Okay. Correct? Definition of tangent is sine over cos. But now then, do you have any trouble here? So one is sine x, one is 4x. To use the limit property, what should you do? I just want x. So I should place this 4 away. I don't want it. Put it aside. But in this case, are you happier? Are you happier? When x goes to 0, 4x also goes to 0. So you can use the special limit of the sine 4x over 4x. Here, that's like what we did just now, 1 over sine x over x. But here, does this limit exist? When x goes to 0, 4 cos x exists or not? Last week material, cos x is a trigon function which is continuous at every point it defines. So it defined on 0, so the limit of this guy is 4 times cos 0, which is 4. So 4 times 1 times 1 is 4. And this limit is 4. Okay, try write down the details. I will provide the full step in the lecture note. Okay, before we break, I let you see what happened. What are we doing in our calculation? So I have a GeoGebra to help me put up. Okay, so this is what happened here. So these are the limit points. Okay, the first one we get 3. Okay, so you see we are getting 3. The second one we're getting 0. Okay, and then the third one we're getting 4. See? Okay, so it matches up with the graph sketch. All right, let's break until 11:06. If anyone haven't taken your attendance, you can come to me now. You haven't taken attendance. What's your name? 006. 一男。 Yes.
quiz.
Quiz. Yeah. Oh yeah, sure. Then later I can talk about it.
Can,
Okay.
can we just do the quiz like this book?
Well, let me think. You can do this in this book, but the problem is the size might not be in A4. So
So I have to print the equation.
no, you need to upload it. Upload to the Moodle. Okay, maybe later I will give you instruction. Yeah, any more questions? Later I'll answer together.
Can I see like the material when I do the quiz?
Can I see what?
The material like maybe the
Yeah, you can use the material, right?
yeah.
You mean check the lecture now, you mean?
Yeah.
I think so. Yeah, I'm sure you can use. Because it's at home, I cannot.
Or even Google.
The point is you cannot copy. You should write down your answer, your understanding.
Yeah, but you can just see Google or anything.
I mean, like,
The one
yeah, one thing is no one knows. Second thing is, I mean, don't just copy plainly.
Yeah.
Okay. Yeah.
Oh, it's a sign.
Yeah.
Yeah.
Oh, okay.
I attend the competition.
Oh, okay.
I think that. Wait, 013. Oh, there as well. Yeah.
Okay.
Thanks.
Yeah.
What the answers is? Try.
Let me see.
If you don't use
A to the A.
yeah.
One way is you. What's A? A is I mean, is it possible?
Yeah.
So A is any real number.
Yeah.
Okay. At first, I thought I want to use the binomial. But this one is random A, so I don't think we can use the binomial expansion. So without is this the answer or you're trying to
I use a Lambda rule to
find this?
find this.
You mean if without Lopita can you do it?
How to solve it.
Okay. Oh, can we do it? Oh. Can we just use any info? This is a very careful. I think what are the tools we have? We only have limit law for limit question. Nothing else. Unless we can do some algebra on this, but this A could be like integer. Do you have expansion on that? I mean not integer, I mean like fraction.
Yeah.
You correct. So I don't think there's any tool to use. unless, I mean, do you know this answer before or you don't know? Are you asked to show that this is equal to this or you asked to find this?
This is my answer. I don't know whether it's true.
Or you don't know whether it's true or not,
Yeah.
this answer?
I just want to solve this, but I don't want to use the rule.
Yeah, so it seems like this answer is possible because if you, I mean, I think using whatever we know in this class, right, the rules, I think it's not useful unless you prove from the definition.
Beyond this class.
Beyond this class, yeah.
Beyond this class.
I think you need to use the
What?
epsilon n definition. You know, there's a section on that
You can
in
write.
the textbook. I didn't teach in class, but you can read the textbook. I think textbook got it. I think where's the textbook? And beyond this class, it is so fine. There's a section on precise limit definition. Precise definition of limit. This one. I think you need to use this. Use this.
Yeah,
So,
I know that.
you know this?
Yes.
So in this case, you should take x minus, I think you should take fx minus L, right? You should take xa minus AA. You sure you don't have a minus sign? Oh, okay. And then you need to take x over minus A and then take away AA. And then you need to check this. If you can find this delta such that this less than epsilon, then you show it. Yeah. But I don't think any rule can help you because the quotient rule doesn't work. And then unless you know how to express this as a factor of this, you know that?
Just like log x equal to x minus 1 when x
But
like this.
but even this, if you write this right, actually it means something like this.
Yeah.
Yeah. So this is not very precise.
Yeah.
What I want to say is unless you can write it as xa minus a to the a equal, not approximate, must be equal, x minus a times something, then you are good. Yeah.
Okay.
And then this thing should go, or you use this.
有个跟做法可以吗？地方是 U 的 x，
所以你的意思是说本来是 x 嘛，这是 x，然后 u 等于 3x，对不对？
对。
对啊，这个做法跟我刚才那个做法是一样的，你看得出一样，看得出它是一样的。Hello, testing. Okay, let's come back. Sure, continue. So we continue with trigo derivative. So if you differentiate sine x, you get cos x. And then the other different thing was if you differentiate cos x, you get minus sine x instead. Okay, so this is something you want to remember. So the shape is like this. Oh well, before we start, since all of you are here now, let's talk about the quiz. So if you open up the Moodle, right, I already set out the quiz section, but you won't see question yet because the question will only release on 3 p.m. on Tuesday. So Tuesday we don't have class, so you should start and do it at your home. And then we have class in the morning, right? And then you still have a bit of time to do until 3 p.m. So please don't leave it to the last moment, because in particular, I think you are very aware of the web speed here, right? The internet speed. You know, don't leave it to the last 5 minutes and then you email me, teacher, I cannot submit now because the internet doesn't work. I tell you, please don't leave it to the last minute. You understand how worse is the internet speed here. So please do it as soon as possible. Okay, and then I set up a quiz here. Okay, so the quiz scope is just topic 1 to topic 2, continuity, no differential derivative. Okay, so please do exercise based on this. And then it's a take-home quizzes, right? Obviously, you might want to get some reference, okay? But the point is you don't copy. Okay, understand the step, write down in your own word. Okay, if you copy, I also cannot help you. Okay, you understand? So please write down in your own answer. So what should you do? You will print out. I mean, either you print out or you use your apps to write whatever now electronic devices. Please write down your name, your ID. Okay, very important. These two things. And then you could write in a A4 paper or what. And then you either you screenshot it, take a picture, scan it actually. Okay. So when you take picture, right, don't take the blur picture. I cannot see. I cannot mark. Okay. So after you take the picture, make sure that you yourself can read it properly. Okay. Sometimes you use pencil, make sure it's dark enough. Okay. Otherwise, it's blur. I cannot see as well. Okay. If pencil dark, I mean blur, your photo blur, and then I cannot mark. Okay. So if I cannot mark, most probably you get 0. I tell you, we won't let you submit a second time. Okay, because we already give you a whole day to finish it. Okay, so make sure everything is done properly. Okay, don't keep it to the last minute. So this is an individual work. So don't try and put a group answer there. Okay, so you do it yourself. Yeah. Okay. Cannot discuss with me. Don't message me. Okay. So but I already teach you the lecture notes, so try and see from there. Okay, see from the lecture note. So yeah. So make them clear, easy to read. Okay. So as also name your file like this so that we can easily track you. Okay, because we are so many of you. Okay, so we need to track you one by one. So please put down your ID and then underscore your name, first name, last name. Do you know what's your first name, last name? Right, you know, right? Okay, last name is your surname, and then quiz one .pdf. So later I will open this up. For the moment, I think if you open it up, there's nothing there, right? Yeah. Okay, so later 3 p.m. it will get open on 21st October, and then the question will be yes. You are not what? No, not in the class. This is a take-home quiz. Yeah, this is a take-home 24-hour quiz. There's a take-home quiz. Huh? Obviously, no, because it's only open at 3 p.m. Yeah. Huh? Sorry?
After we, after it, or
Yeah, after 24 hours. So the opening is 21st, 3 p.m., right? So it will close at 22nd, 3 p.m. So within this period, you should submit your quiz. Okay. So this timing include answering the question, includes uploading the question. Okay, so please don't leave it to the last second. And in particular, you should check your timetable. So you have your freedom to arrange your time to do it. Okay, this is the point of take-home quiz. Okay, any other question? Know how to submit? Okay. All right. So in case really at 3 p.m. you cannot submit, you should email me. After 3 p.m. I won't accept any submission. Okay, on the 22nd. Okay, in case there's really some internet problem or what, you can email me. Otherwise, please keep to this deadline. Okay, right. Okay. Yeah. Okay, so if you plot out the graph, right, so you can see that if you look at the sine x graph, okay, then you see how your tangent line move. So you get the gradient, it exactly move like a cosine function. Okay, cosine function. Okay. So now you understand how your cos theta come from, your cos function come from, because your cos start at 1. So remember just now we have a limit property that sine theta over theta is 1. Okay, so it start at 1. Okay, so this is secretly, actually, this is how we define sine and cos function. Okay, we define sine and cos function actually using the derivative way. 1 is a derivative of theta. Okay, better. Okay, so now you will know better how you draw your cos theta function. All right. So, yeah, maybe not do this lah. Can you tell me how to do this? Teach me. You teach me. Teach me. You teach me how to do this. Sorry? Yeah. You? Yeah. No, try. Try. It's okay. Try. Never mind. Everyone have chance. No worry. I try. It's okay. You can start from there. Let's see how it works. Oh, you want to say the answer? I don't care about answer. I want the step. I want the step. This is how we mark, right? We want to mark your step. We don't just mark your answer. If you just put answer, no step, you'll get 0 marks. Okay. Then how you get answer? You memorize answer. You memorize. You in China you do that? Oh my goodness. Oh, okay. How about you tell me answer first, and then see if we can figure out the step or not. What's the answer? A plus 2 sine x. Do you really don't want to try step? No step? No step? No step. Okay. Sorry?
Our next step is the answer.
Your next step is also this answer. Ah.
We can divide it to the different, but
Yeah. You need to divide, right? I mean, like, you need to separate the differentiation. This is also the step. This is the step I meant. This is the step I meant. You can do the linearity, pull out the scalar, something like that, right? Okay. Forgot everything what I say. Okay. So the step I meant is this. So you should realize that, let's do the backward engineer. So you should realize that cos x is actually the derivative of sin x. And then, what is sin x? Sin x actually is the derivative of minus cosine x. Or, okay, if you don't like this, right, maybe you can do this. So this is a minus, like that. Okay, then minus sine x should be the derivative of cos x. And then here is a minus. Then why can you go from the first step to second step? Because this derivative, this differentiation exists, this differentiation also exists. So you can use the linear rule. Okay, now this is the step we are looking for. If you just write down the last step, correct, 0. No step, correct answer, 0. I give you 0. Okay, we all set already. All the lectures set already. This will be 0 1. Okay, if you have some step, but final answer a bit inaccurate, what do you think? Do you give marks? You give marks, huh? I also give marks. Okay, so we give marks for step. Okay, if last step is wrong, maybe we deduct 1 mark like that. Okay, if your step makes sense, we give that mark to you. Okay, so to make sure that you know you are using, what are you using? Okay or not? Make sense, huh? So this is a bit different from your senior high school already. So please take note now. Okay. Again, find equation of tangent line. I think we can skip this. Okay, it's just that this kind of tangent line is a what is this? This is a trigger function. Okay. Hey, how about 3.17? How about this? What do you think? They are trigo, they are polynomial. So what you do here? Huh?
Yeah.
Ah,
We should divide like it's another variable like x squared to the u and minus x.
yeah. So what's the method we call that? What's the rule we call that? Good, very good. Okay, so this you should use the product rule. Okay, u equals to x squared, v equals to sine x. Okay, and then you compute what's the derivative, and then you just put them following the formula. Correct or not? Okay, so this is like pieces of Lego, you know. You should see mathematics as a Lego, you know. We want to break it down, and then we do something, and then we combine them. Okay, so d over dx of x squared sine x is equals to u v prime plus vu prime. Okay, go and add it up. Okay, so here we are using actually product rule. Okay, so I left it for you to complete. How about this? What to use? You see quotient, you want to try quotient rule. Okay, you could try quotient rule. Okay, you try using quotient rule. So if you use quotient rule, what's your u? What's your v? U is the numerator, and then v is the denominator. Okay, then you need to get what is your u prime, what is your v prime, and then what's your v square, and then put them together. Another way, can you try another way to do this question? What if you know how to differentiate 1 over cos x? What if you know how to differentiate tangent x? Again, if you can do this too, then you can do the separation. I mean, like term by term. I use the linear way. Okay, if you know how to differentiate this two. Okay, if you know these two, then you can separate it. Make sense? Okay, because 1 plus sine x over cos x is just 1 over cos x plus sine x over cos x. Sine x over cos x is what? Tangent x. Okay. All right. Good. So now we discuss what is different derivative of tangent x now. Okay. To prove this actually a bit hard. A bit hard. So you just remember. You know what is secant? Secant. Don't know. Huh? The inverse of cos, right? Okay. So sec x is 1 over cos x. Okay, and then cosine is equal to 1 over sine x. Okay. So maybe you want to remind you yourself, 1 over cos x is not like cos inverse x. It's different. Okay, it's different. Don't confuse yourself. Okay. 1 over the function is not necessarily inverse of x. Okay, although like x to the inverse is like 1 over x. Okay, it's different. So please don't confuse yourself. So if you divide, if you differentiate tangent x, you got secant square x, and then if you differentiate cotangent, we haven't defined cotangent. You know what's cotangent? Cotangent x? Anyone know? 1 over tangent. Good, very good. Okay, so you get minus cosine square x, and then if you differentiate secant x, you get secant x tangent x. And then if you differentiate cosine x, you get negative cosine x tangent x. Actually, I think most useful one is the first one only. The rest we seldom use. Okay, then you can do this calculation. I think we can skip. These are the similar type question. So basically, you just apply the derivative on this curve tangent x. For the first one, for example, if you want to find the tangent line, you want to find the gradient. So you want to differentiate tangent x, but I already give you the formula. Just use it. Okay. How about 3.2 then? What's the rule you want to use here? There's polynomial times cotangent x. So you should use product rule. Okay. And then sine square x. How about sine square x? What is sine square x? Sine x times sine x. So you use also product. Okay, okay, so far okay. Let's go down here. Should we do this? How about let's discuss also how to do this. See if we want to write it down or not. So an object at the end of a vertical spring is stretched 4 cm beyond its rest point. So it's written as a picture there. So you rest at 0 and then you stretch down 4 cm. And then release at the time t equals 0. So you need to start with time 0. And its position at time t is x equals to ft minus 4 cosine t. Does it make sense or not if we use this model to describe this motion here? Because if you stretch this spring down, can you imagine what happened? It will bounce back. After bouncing back, push away. And then bounce back again. Push away, bounce back again. But now I think they assume there's no friction, air friction. So you can keep this motion forever in a symmetry way. Okay, so up, down, up, down, up, down. But why is it cos? Cos is like there's a horizontal motion, right? So you should think of it as a time at a different time. Okay, although the position is at the same position, up, down, up, down, up, down, but if you add in the time variable, then you'll be at different time, different x. Okay, so we use cos 2. So you want to find velocity acceleration. So this is a displacement function. So velocity, how to find? dx dt. Acceleration, dv dt, which is dx d2 x dt square. That's it. Okay, yeah, that's it. Okay. So we skip this, yeah. Everyone okay, So you just compute v as dx dt, and then a to b, d v dt, which is d2x square. So the changes here was I just changed my displacement function into trigo. So this is a bit like we try to convince you this basic function is really important because this is what you see in real life. Okay, this is what you see in real life. Get this type of function here. Okay, everyone good? Good. Okay, we're gonna leave here. We're gonna go to chain rule. Okay, let's look at this example. Let's look at this example. What would you do at first place? Actually, there are multiple ways to do this. What's the first way you will do? Let me interview some of you. Right here. You, what do you do? Expand. Okay, the first thing you expand. I think you know the hard way. And you expand it. Okay, good. You can expand it. So first way is to expand it. Why you think that expand will work? Can you tell us? And why you think that expand is good? At least good for you. Sorry? What do you mean by not good? Why you give me something not good? You should give people something good, right? What do you mean? What do you mean other formula? Expander is okay. Expander, just expand. So you just expand. So why expand will work? Expansion. Can you tell me? Why your instinct tell you to expand? So actually expansion, there's a few terms here, right? But you know that you know how to differentiate all these terms because these are just polynomial. Okay. So that's why your instinct tell you to expand. Can others tell me different way or not? Say. Okay. Okay. You are going ahead of me already. I haven't teach that rule. She is trying to she's trying to explaining the chain rule. Yeah, I'm not talking that yet. So based on what you have learned, what else you can do? That is chain rule already. Other than that, yes. Yeah. Product rule, very good. So the other case is you see this as a product of two functions. How to see? Maybe you set u equals to x squared plus 2x, and then v is x squared plus 2x squared. Okay, so you do product rule on this, but you realize that you also don't know how to do this. Then what do? Again, product rule. So it's like inductively do product rule. Keep doing product rule. Can you imagine what I said? You should try it out yourself. To try out yourself. Okay. So it's like x squared plus 2x. You should go back and try. I suggest you. Okay. So and then this square prime plus x squared plus 2x squared and x squared plus 2x prime. Okay, but again, you need to use product rule on this term again. Okay or not? Okay, inductively doing product. Okay. Any other method that we learn can apply here? I think that's it. Okay, these are the two methods that we can use so far. But now we're going to introduce a new way called the chain rule, like what your friend said, substitution, change variable, okay, equivalent name. Okay, so what we're going to do was this. So first let y equals to fu. Okay, to easier describe our chain rule. And then we'll let u equals to gx. So this is the substitution described by Madhya. Substitution. Okay. So let's say if g is differentiable at x, okay, and then f is differentiable at u. This is a bit like the limit condition. If the limit exists at g, and then f will have this. If continuous there, then everything is continuous. Then we will know how to find the derivative of a composite function here. Okay. So previously, we also have this kind of sequence. We find limit, and then we want to find the limit of a composite function. And we have a continuous function. We want to prove that the composite of continuous functions is continuous. Now it's the same. We have differentiable function. We want to prove that the composite of differentiable function is again differentiable. Okay, so the sequence is the same. Okay, for these three chapters here. So what do was how to differentiate the composite. First, you differentiate your f at gx and then multiply. This is multiply and not composite anymore. Just multiply with the derivative of gx. So because after differentiate, this is just number. These are two numbers. So I just multiply the two numbers together. Okay, so this part is number, second part also number after derivative. Okay, I just multiply two numbers together. So you go from a composite function to a multiplication of number. Okay. So in short, this is one of the instance it looks like it's suggesting that dy dx looks like a fraction. You can imagine like dy cancel it with dy. Okay, but in general, it's just dy over dx. Okay, let me write down the form that we discussed just now. So seriously, this is d over dx on y equals to d over du on y times d over dx on u, like that. Okay. But if you write in the form at the left, this is really like a adding du over du. But that operation is illegal, but this is the reason. Okay, but you can use it as a way to remember the chain rule. Okay, so du over dx equals to dy over du over dx. So what's the u here? So where's the u here actually? So maybe I should write it more generally. So secretly, okay, when you talk about y, right, you should tell me what is the y depending on. Okay, actually this y is depending on gx. Okay, and then u is just the gx. So you differentiate with respect to gx actually. Okay, so this one I still keep with y gx. And then how about the u? The u is actually the gx we are talking about. Okay, so maybe sometimes we write y, x, u, we never know what's the function it depends on. Okay, so actually this y depends on gx, and then gx depends on y x. Make sense or not? You can only differentiate with respect to the variable it is. You only can differentiate the function with the variable inside it. Otherwise, you get 0 because there's no variable. It's not changing. This function is not changing. Okay, so you see why we can do d over dx on y dx because there is a variable x inside there. So you can do it. So why I can differentiate y gx with respect to gx because gx is its variable also. Okay. And then you differentiate dx with respect to x because g is a variable. G has variable x. Make sense? Okay. So I mean, like, there's a lot of info that I gave you within a lecture, right? So hopefully you can go back and revise again. Okay, that's why I do recording. You can play again what I say. All right. So let's apply to this case here. Okay. So in this case, expansion won't work already. Can you do 60 times? So it's harder. So that's why we make you harder. You have to use chain rule now. Even using product rule, you also need to do 60 times. Okay, so that's why we make your life very hard. But I give you another easy tools to use, right? Which is chain rule. Okay, so to use chain rule, what do? You need to set your u right just now. Okay, so set your u first. So what u is easy for you? What do you think? Which u is easy? Remember, your u is depending on x or not. So what part is easy? Can I fix 2x squared minus 4x plus 1 to the 59? Can or not? It's like almost useless, right? Okay, so let's not do this. Let's do just 2x squared minus 4x plus 1. Okay, then I can rewrite my y as what? Y equals to u x to the 60. Okay. Why is this useful? So by chain rule, still remember the formula for chain rule? dy over dx. How do you remember? It's like a bit of like fraction, but it's not entirely fraction. So dy over du times du over dx. Okay. So you see, I already write y in terms of u. Do you know how to differentiate that? It's just a polynomial in u. So what do you get? First part. What do you get? dy over du. Felicia, what do you get? dy over du. Yeah. Not divide, not divide. Please don't say divide. dy over du, yeah, the answer. Yeah. Look here. Don't look down. Look here. The question is here. y equals to u to 60. Good. Okay, you can do this. Okay, previously you don't know how to do because inside here is not x. Okay, so now you can do it. 60 u to the 59, but how about du over dx? Can you do it or not? What do you get? 4x minus 4. Okay, but the question is not done yet. The solution is not done yet because dy over dx. What do you expect? What's the solution be? You differentiate with respect to x. Your solution should be in x, but you got something in u. Or how to turn it to something in x? Yeah, you substitute back because I already know how to express u in x. Okay, you substitute back. Okay, you substitute back. So altogether you get 60 of 2x squared minus 4x plus 1 to the 59 multiplied by 4x minus 4. Okay, like that. Okay, good. All good. Okay, how about I let you try these two questions here? I give you maybe 2 minutes. Try it. Yeah, try these two questions. See what's the u you can set to make your life easier. I mean, you should try a different U, so that you would get a hunch. Okay, when you do this kind of question, what U is easier for your computation? You can try different U. Maybe some of them will work better than the other. Okay, so okay. Okay, anyone try what U for 3.25 here? Anyone try? Any U? 2x 5 to the 7 because we can make my y to be u to the minus 1/3. Okay. Then in this case, by chain rule, you dy over dx, you will get dy over du, which is easy to compute, and du over dx also easy to compute. Okay, can you tell me what's the final answer? Anyone got the final answer? Huh? Anyone? No one. Haven't finished compute. Huh? Minus 1 over 3. 10, huh? 10 times 1 is 10, right? Okay. X to the 4. Then 1. 1 times what? Finish, done. Square root, cube root, 2x.
times by, I mean the
numerator.
Yeah.
Okay. 2x.
I mean the bracket
You need a bracket.
of
Then
of five
half 5, 7
power of
Mm.
before
Mm.
over
over 3. You know that we will place this at the bottom. Okay, so we could place it at the bottom like that. Like that. Okay. Okay. Yeah. Okay. So how do you check this solution in general? I mean, is there a calculator to help you or not? Do you know how to check your solution? You can ask a calculator to help you. Maybe you can use this symbol lab. I think symbol lab is quite good. So just now we do differentiation, right? Where's the differentiation? Here, differentiate. Let's put in this. Where's my fraction? Oh, yeah. And then 1 over. Yeah. So we have a cube root. So here is put 3. And then 2x to the 5. And then minus 7. Let's see if we get the same answer or not. Yeah. Okay, we'll get the same answer. Okay. So these two is to help you, but not help you to copy. Yeah, so you should use these two to help you to learn whether you compute the right answer. Okay. Some of them they will show you steps, then you can even check whether your step is the same or correct or not. Okay. I think another place you can use is you can try Mathematica. I think you also can use this Mathematica. Right. Sorry, this is the product. Where is the compute the answer? Is it this one? Yeah. Okay, so you can input your maths. Okay, so you can differentiate how many times. This one can even change your variable, and then you have cube root, right? And then 2x to the 5 minus 7. Yeah, this one even plot for you what happened, okay, with this function. Okay, so please use these two to check your solution. I just not doing for blank too. Okay, I think there are more nowadays, so you can try and figure out. But ChatGPT is not very reliable on calculation because the step always wrong. And so you need to be careful when you use this chatbot, AI chatbot. Okay, how about 3.26? What's your U? You will set everything inside the power as a U, right? Okay, and then you differentiate your U will be using the quotient rule. Okay, so we are combining rule to use. And then you should get some very long answer. I don't think you can simplify it. Yeah. Okay. So the rest is very similar. 3.27. What do you think? What's your U? 3.27. What U you can set here? So what U you can set here? The basic function is what? Sine x. So to make it basic, you just set U equals to 2x. Then you can do the differentiation on both. Then how about this? How about this? What's your U? This one a bit tricky. This one a bit tricky. But you should try first. Okay, so let's say if I set the first thing I think you should try is y equals to u square, right? Okay. Then is this useful? Well, I mean, like from the previous we know, or we haven't know yet. Okay, then that's not good. Maybe you can start with differentiating gy, which is sine u. Do this first. Okay, try and find g prime u, g prime y first. Find g prime y using chain rule. Okay. Then we can write fy to be y times gy. Then you use product rule here. Does it make sense? Okay. Anyone tempted to use y equals to square root u? Anyone tempted to do that? Is anyone tempted to write this down? Square root u sine u like that? Anyone want to do this? I'm not sure if this is helpful. Maybe you can try it here. Then you, yeah. Maybe you can try if this is workable or not. Okay, otherwise, the next step you use product rule. Fine. F prime. Okay. Yeah. How about this one? Is it obvious what you want to set up? Obvious. There's like product, quotient. I think just do by quotient is very easy. Just use the quotient. But I think you start with quotient, right? Do we start with quotient? I mean, the way I try, I think I will start with quotient first. So maybe I start with, so first step, I start with quotient rule. Okay, so I start with u equals to x squared 1 minus x cubed, and then v is 1 plus x. Okay, but you realize that when you compute u prime is involving products. Correct? If you do u prime is a product rule. Correct? Do you know what the product here? X squared and 1 minus x cubed. Okay, so you involve product rule here. Okay, so here you need here involve, so finding u prime involve product rules. So let's give some more names. Let's say A. So I'll use another color now. So A equals to x squared, B equals to 1 minus x to the cube. But what did you realize when you do the product rule? You want to find B prime. But to find B prime, how to find this? Just now we use a chain rule. Okay, so here you need to use chain rule. I think you could get everything. Okay, after you get chain rule, put it back to product rule, and then put it back to quotient rule, and you can get the answer. Okay, can follow? Okay, maybe we can stop here, but do you have questions on this part here? And go back and try compute everything. Okay, okay, so get the step and then try compute it. In that case, I will see you next Wednesday. Okay, please be aware of the quizzes.